Today, on How We Know What We Know, we will be tackling the age-old question of how old is something. Archaeology is a discipline invested in the past, and age is a very crucial bit of information in understanding sequences, changes, and the context of what we find. Once upon a time, the only way to distinguish age was with stratigraphy, a relative dating technique. The principle of stratigraphy is quite simple. The oldest thing will be below the younger thing as long as nothing was disturbed. This is considered relative because we are not finding out its actual date, but we are judging its age based upon something else. For example, A is older than B, C is younger than D. These dates are not exact, but they can still be quite useful in initial analysis. However, we need something far more precise. A far more precise dating technique, or absolute dating technique, is carbon-14 dating. This method revolutionized archaeology because now we could date something to a pretty precise age within a certain margin of error, often given in plus or minus so many years. But how does this dating technique actually work? First, we need to set its limitations, which are 1. It can only date organic samples, so no rocks, no stone tools, and 2. It is best used on materials no older than 50,000 years old. Anything beyond 50,000 is usually best left to other dating techniques. To understand how carbon dating works, we need to know some physics and chemistry. Carbon is a stable isotope as carbon-12 and carbon-13. Carbon-14 is a radioactive isotope, which is why carbon-14 dating actually works. Now, carbon-14 is produced in the atmosphere through the interaction of cosmic rays and nitrogen-14. After this interaction, carbon-14 often binds to oxygen, creating carbon dioxide, and this is how it is absorbed into organic material. Carbon dioxide is used by plants in their process of photosynthesis. As plants absorb the carbon-14, other animals will come along and eat the plants, and this is how carbon-14 enters the animal food chain. Now, when an animal dies or a plant dies, it stops taking in carbon-14. And because carbon-14 is radioactive, it will decay over time back into nitrogen-14. With a half-life, or the amount of time it takes for half of a sample to decay, being approximately 5,730 years. It is this radioactive decay which makes carbon-14 useful as a dating technique. The general principle behind the dating technique is by studying the amount of carbon-14 left and the amount of nitrogen-14 produced by the radioactive decay, the ratio between these two isotopes will be able to tell us how long ago this animal died and stopped taking in carbon-14 from the environment. Simple enough. Well, not quite. There are a lot of variables that need to be controlled for to get an accurate date. A big variable is the amount of carbon-14 in the environment during an animal's death. We can't assume the amount of carbon-14 back then equals the amount of carbon-14 today in the environment. This is because, not surprisingly, the amount of carbon-14 within the environment changes over time. A stark example would be above-ground nuclear testing during the 40s and 50s, which increased the amount of carbon-14 in the atmosphere to peak levels in the early 1960s. Recently, it has also been noted the amount of carbon-14 can vary depending on geographical locations, such as whether you're in a forested environment versus an environment along an ocean shore.
Created using Powtoon.